Hello everyone and welcome to this session on SQL. I welcome everyone, and today in this session we are going to talk about different concepts, the basic concepts of what is an SQL, and we will talk about how do we create tables, two-dimensional tables. We will take our sample database as MySQL as an example, and I'll show you how you can write queries, and then we will discuss about different type of SQL commands, SQL command structure. We'll show you certain examples, and with that you will be able to visualize that how SQL helps you in writing, in analyzing data, which is the most important thing as of today. So we will be writing certain basic SQL queries and functions. Then we will get into different modularities of SQL writing, different complexities, like I'll explain you how to use group by having, very similar to like we make pivots in Excel, which we use day to day. But it's very important to understand and correlate that the way we use and draw pivots, how can we do that in SQL and get the desired results. And then joins and subqueries, that is also one very essential part of your analytical skill set, which you might be using subconsciously in your day-to-day life, as you must be using VLOOKUPs in Excel, or you must be joining two worksheets. But we will be doing this live with certain examples, the example data which we will create for our session today. And so during the end of the session we will cover how you can write joins and how you can join two tables. So with this background, I'll move ahead and talk about what we're gonna cover. Now, what are the widely used databases? Let me just quickly okay, so let me just give me a second. Okay, so what are the widely used databases? You have MySQL, Oracle database, MongoDB, SQL Server, Cassandra, and others like Hive, Latin, Pig. Just why is it not changing? Okay, so okay, so what are the widely used databases, right? Okay, so these are the certain widely used databases like MySQL, Oracle, MongoDB, Microsoft SQL Server, Cassandra, and then you have big data databases like Hive, Impala, etc. Now, MySQL, Oracle, Microsoft SQL Server, they are the most old legacy-based databases. They are there in the market for pretty long, and they are generally two-dimensional databases where you create tables like a typical people who are not from SQL background or does not understand the keywords like table. I would just try to explain them like a table is nothing but like your Excel worksheet which you use in your day-to-day activity, and you have like your Excel headers. You create headers and then you start collating data in Excel. So the headers are nothing but called columns in a database table. So typically in a two-dimensional database, you start creating Excel sheets kind of tables where you have to start inserting the data, So all these MySQL, Oracle, Microsoft SQL Server, they are based on that particular concept. Now there is a second generation of databases, second gen, which have been prepared with the new advancements, where there was a need due to the new technology advancements that you wanted to persist documents, JSON, JavaScript based JSON objects, structured objects, or you want to persist some other documentation like XML, JSON. These are the typical data structures which are now being used widely. So MongoDB, Cassandra is basically that generation of databases where you can directly persist certain documents, and you can query on top of that. So these databases are called NoSQL databases, MongoDB and Cassandra. It means not only SQL. It means that you don't only create or persist two-dimensional data, but you can also persist a document which is in JSON, XML, or any kind of format, and then you can leverage the query language, structured query language, SQL, which is compatible with their platform, and use that to query that particular document. So that is like the more advanced level, and then you have big data databases which can carry huge amount of data, create replicated information for backup, recovery, and for fast retrieval of information. So now in this era where we are living, we have information getting generated every millisecond. You have huge applications like Twitter, Facebook. You have information getting generated from IoT devices, Internet of Things, per millisecond. So now the big data databases are meant for capturing such an information which is huge in volume, terabytes and petabytes, and then these databases are up to that level which allow you to easily, efficiently, and again you have to use again a structured query language only, and SQL only, in order to retrieve that information. So ultimately, whatever the database, underlying database it is, whatever technology, whatever platform you use, whatever vendor product you're using, either using MySQL, you're using Oracle, Microsoft, but conceptually you need to understand, or you need to learn how to write a structured query language, and that is what here we are for. Okay, now what is SQL? Structured query language. SQL is the language to communicate with the database. Very plain, simple. So basically, even in Excel, you can write certain queries, Power Query. There is an example. There are mechanisms today. So each and every tool, either it's a database or a standalone tool, will give you a mechanism in order to write queries and retrieve information. So query writing is into multiple segments. We will discuss that in our subsequent slide, and then we will move on to some live examples when I'll share the example on how to create your database in Query it. But SQL commands are very important. Now, a lot of people aspire to move into data analytics, or probably they are using data analytics in their day-to-day job, but they are not syntactically aware, or they do not have that skill set to syntactically query a database. So then, this session which will help you understand, or basically give you a perspective on how you can create a query. Okay, so SQL commands help you store. So SQL is not only for retrieving information. You can also persist. You also persist the information, save the information using SQL commands. So you store, you process, you analyze, and you can manipulate the databases. You can basically change the underlying architecture. You can change the underlying tables. So for example, you created a column in which you were expecting that only numbers will be inserted. So when you created a table, you defined that, okay, the expected value in this particular column is always number. So you defined a data type of number, to assign a data type of number to that column. But later down the line, you realize that, okay, that column can accept alphanumeric, right? Integers or strings, or string integers like ABC 123 or 123 DEF, these kind of values can come. So then you can go and change the data type of your column in the backend, right? And so like in Excel, when you do a right click on a particular column and you change the format, so like similarly, you can go in database and change the data type of that particular column. But that is something which you need to be aware of while designing your database, right? Okay, so that is the whole objective. Before anyone who wants to persist information in a database, that is his responsibility, that he understand what kind of data he is gonna receive and persist, whether it is numeric, whether it is decimal, whether it is string variables, or whatever kind of information you are getting, you are expecting. Then in a similar fashion, you need to create your database. Okay, so that is the objective. So now let's proceed further. Okay, so now this is just a sample table which we are trying to show you over here. This is a table called players. You have 4 columns now here, which is player ID, name of the player, the country which he or she belongs to, and the number of goals that player has done. Okay, so now if you see, it's a very simple 2-dimensional structure. Data you have columns, and each column you have data which signify one row. Okay, so now if you see player ID 101, then with name Sam, country USA, and goal 6, this is one row. In database language, we even call it as a tuple. Okay, so this is nothing but one data set, one row of data which you have inserted in this particular table. Now if you observe, player ID and goals, these 2 columns are number columns, and name and country are string columns. So that is the way you would have, when you would have created your table, it would be mandatory for you that you decide what data types or data type or what kind of information is going to go and sit in the respective column. So that you have to define initially itself. Okay, so we will take a look at that. I will try to create a table for you, and we will see how, and we will insert information in that. So just to further analyze, you have 6 players data. So you can now suppose if there is a analysis to be performed on this table, there could be so many different kind of analysis which can be performed. One question, analytics can be how many total goals have been done by across all the players. So exactly what you will do, you will perform a sum of all the goals, which will be 13, 23, 29, 34, 37. So 37 goals have been done across, right? So now if I have to write a query in order to get that particular answer, that is what we will try to see in our session, right? So how syntactically you can get that number of 37. Second query can be that per country how many goals have been done. So here we have all 6 countries are unique, so all you will get the same answer what you are seeing over here. But if suppose there is a country which would have been repeated, then that number of goals would have got added. So we will support all these statements with an example. Okay. Okay, now moving ahead to understand 4 basic different type of SQL commands which you can perform. Now, as I said, you can insert information, you can select the information, and then you can do certain other operations apart from insert and select. So we will see that difference in this particular slide. So there are 4 kinds of different SQL commands. One is DDL, which is data definition language. This command, the set of commands which fall under the category, allows you to manipulate or play change the tables. You can create a table, you can alter the table. So the example which I was mentioning earlier, that you decided that whether a column, you have to move a column from number to string, then you can go and alter the table. So alter means modifying the table. Drop, you can easily, if you have accidentally by mistake or you have created a redundant table, then you can go and easily drop that particular table. Or you can truncate the data at one go. You can delete all the rows in the table. So all these kind of manipulation of data or playing around with the tables comes under the data definition language. All the syntax, all the commands come under this particular category. Then the next category is the most important one, which is data manipulation language, DML. In this category, all your updates, inserts, delete commands, all your select queries, analytical, group by, joins, inner joins, whatever we're going to talk about primarily will fall under the DML, where, like the example, select all the players from your table or get the sum of all the goals across all the players. All those kind of queries which you will be writing will come under DML category. Now the third is data control language, which generally every database has in order to provide permissions, what kind of permissions, what kind of activities a database user can perform on the database. So there are grants which a database administrator can perform and provide different security levels to each and every different kind of user of the database. So there generally you have one database administrator and you have multiple database users who can perform select, insert, update. But generally the database administrator has the highest level of access to maintain the database, to maintain the parameters of the database, to monitor the health of the database, to tweak the processing power, or to monitor the memory the database is consuming. All those kind of activities generally are done by DBA. So you don't want to give that level of access to everyone, because it could lead to accidentally corrupting the database. So you generally only provide limited access to the new users which you onboard. So you can grant different levels of access or you can revoke. Okay. The fourth one, the transaction control language is something which allows you to commit the information. So each and every database comes with a two-phase commit. One is that after you have inserted the database, you need to commit the data information. You need to basically tell the database, yes, you commit this information which cannot be deleted, means which if not provided deleted command will not get deleted. So that is called two-phase commit. Generally you have a provision to do an auto commit. So if you provide that provision, then every information which you are persisting, inserting or updating will automatically get committed in your database. And then you also have the provision to roll back. If you have inserted accidentally or if you do not want an information which has to be committed, you can roll back. Now these transaction control languages, the commands, can also are very helpful when you are interfacing with your database from your programming languages like Java, JavaScript or .NET. Generally you use interface with your database. So you create in your programming language, before you start a particular database session, you generally say auto commit off, and when you have done all the business logic relevant in your programming language, you do a commit after you have processed run your entire business logic. Okay, so generally when you are doing programming, you are writing your JDBC code, there these kind of features are very helpful. Okay, I'll just take up some queries which are I'm seeing on the portal. What is the difference between SQL and NoSQL? So basically SQL is structured query language. As I told, generally it is more it's meant for two-dimensional data, and NoSQL means, actually it doesn't literally mean NoSQL, it means not only SQL. So it is an additional feature on top of SQL which allows you to query structure different kind of documents like XML, JSON, which are structured data sets but lying in a one single column or a one single cell in your database. So you can go navigate to that particular nodes of a JSON or an XML and fetch the information, which is not possible in a typical SQL oriented database. Okay, so now if you see, this is a typical select query structure. You select the name of the columns, column 1, column 2, okay, whatever columns you want in your result set, and then you start applying filters. Like in Excel, when you select your columns, you generally apply certain filters on the columns. So where clause in your select query is like a filter. Okay, like for example, if we go back to our example in the previous slide, if I want to say I only want information of country USA, so you will go and apply filter on country USA. Okay, so that is something that is like applying filter, which is equivalent to where clause in your SQL. Okay, so you go. So again, if you say, okay, I want to apply filter on only two players like player 101 and 102. So in your where clause, you will only select those players which are having player ID 101 and 102. So select query where you are able to manipulate your information. So you have a where condition. Then you have group by. What is group by? Group by is nothing but pivoting. The columns on which you want to pivot, is called as group by. Okay. So for example, in my example when I was talking about the player, you want goals per country. So your group by will be by the name of the country column and the sum of the goals. So your group by columns generally are non-numeric. So in the group by you can only use non-numeric columns like country. You can use by your player name, etc. Or if you want to use numeric player ID, then those should be the columns which are meant for analysis. Player ID, so you will not like to do a sum on a player ID at any point of time, right? So you will always do a sum on the goals. So you can group by player ID, you can group by column the country name or the player name, but you will not do a group by of goals. That number, the number of goals is generally used for analysis. Sum, average number of goals, you want to find what is the maximum goals done. All those kind of manipulation can be done only on the goals column. Now having column is nothing but when you are saying after you have done a group by, you want to filter information after doing a group by. If you want to do the filtering of data before group by, you use where clause. But if you want to do the filtering of data after group by, you use having clause. So basically you say that okay, if any number of any country which has have goals more than 5, then you would have done a group by country, sum of goals, and then you have to say having sum of goals greater than 5. So we will see that. And order by is just primarily for sorting, ascending or descending. Okay, so now with this information, let's go into our database. Just let me try to share. Okay. Okay, I hope my workbench is now visible. Okay, now I'm going to show you some live examples of my data. So what we are going to do is, first I've already created a sample database, but I'll try to create another database for everyone's convenience. So I'm going to create a database called SQL Live Tutorial. Let me call it Tutorial 1. So now I'm using MySQL as my sample database platform over here for everyone to understand. So we're going to use SQL Live Tutorial. You create the database and I'll just make it as my default. Now I'll open a SQL editor which will communicate with my database. Now let me check how many tables are there in my database. Right now it's all blank. There is no tables in my database. So what I'll do is I'll create a table. Now what I'm going to do is I'm going to create a department table. Now please understand over here what we are trying to do. We are trying to create a department table with 3 columns. One is department ID, which is a numeric field, integer field. Then the second is department name, which is a string character field, and I'm defining the length, that okay, not more than 30 characters I am expecting in this particular column, and location, I am not expecting more than 40 characters. By doing this, I am defining the size of my data set which I can persist in my department table, and also I am defining the space which my database is going to occupy on the hard disk. Okay, so you're basically defining what are the data types and the columns which you are going to create. Second table which I'm going to create now is my employee table. So I am creating a department table and the employees who belong to which particular department. So I'm generally creating certain set of columns for employee, like the employee number, code, or whatever you want to call it, naming convention, the first name of the employee, second name of the employee, the job description, what is his designation, the manager, who is his manager, what was his hire date. Now this is a new data type, date field, which is very commonly used. You generally want to capture the timestamps, the dates, and it is a very common thing. Salary and commission, basically the float, the decimal numbers. You are expecting salary to be in decimal, so you will define float data type. And now this column is the ID, department ID, to which the employee belongs. Okay, now generally when you're designing a database, you would want that this column, the column which I'm trying to put in the employee table should be similar to the column which I've created in the department table, and even the values in the employee department column should be same. So for that, there is something called as referential integrity, though we will cover that in our advanced sessions. But for now, conceptually, please understand that there is a concept called primary key and the foreign key. So we will basically, you need to create a foreign key. You will say that whatever department ID value will come in the employee table should be existing in the department table first. Okay, so I'll create my employee table, and then now you can refresh and check. There are 2 tables which have got created, and now again if you say show tables command, you will see that 2 tables are now in your database. Okay, so whatever create commands which we have done, these are all DDL commands, data definition. We have not performed any DML query right now. We have just done some DDL transactions, some DDL commands we have executed. Now let me try to insert some information, some sample data. So what I am doing is I am saying insert into department table values. Now first is department ID, second is department name, and third is the location of the department, and I am going to insert the data. So 5 records got inserted in the table department. Now if you want to cross check whether the information got persisted, you have to say select star from department and run the query, and you will get the desired result. You got 5 rows. So typical 2-dimensional data, columns and rows. Okay, next, now as we have populated the department, let's populate the data in employee table. Now I've already created certain sample data, and if you see the values are as per the column sequencing: employee code, first name, last name, the job, manager ID, hire date, and salary, commission, and department ID. So I've already taken care that the department belongs to the department table. So 17 records have got inserted, and I'll just confirm whether my data is there. 17 rows returned. So all my information got persisted. Okay. Now, if suppose, as I was showing in the presentation, you only want selective columns, you say I only want employee first name, comma, employee last name, nothing else in my output. So you can do selective query, selective column selection. Okay, so syntactically star means that you only want all the columns, or if you want selective columns. Okay, now there's another command which allows you to check what are the details of my employee table. So if I am using a utility called SQL Workbench, so that also gives me these features. I can go on employee and I can check alter table command and check the details, whatever the description of my table is, or you can check what is the description by the command by using this command. What is the description? What are the data types of my columns, whether the null is allowed, any primary key, any key column or not, other than that. And if you have defined what would be the default value of any column, then that will also come over here. So either you can write describe column, or you can say alter table and you can check the details over here. Okay, now the next one is the next example is you want to alter the table. Okay, now in the employee table, as I was mentioning, there is no primary key. Primary key means that the column cannot have duplicate values. First of all, the column cannot have null values, and every value should be unique. So if you want, you need to define generally in every table there should be a primary key which should uniquely identify each and every row, so that there is no data duplicacy. Okay, so now I want to make my employee code column as a primary key. So what I'll say is alter table employee and add primary key, and I'll give the name of my column emp code, and I'll run this. Okay, now in order to verify, you can go and check. If you now go and check your table, these two check boxes are ticked. Now this is what MySQL Workbench has read from the table, or even you can say now describe employee, and now if you see, it is a primary key column and null is not allowed. Okay, so this is how you play around. This is again a DDL command, alter table. You play around with the table. You go, you can make changes, you can make changes in the table, and you can validate. Okay, I'll take a pause and check if anyone has any questions so far. Okay, okay, fine. Okay, now moving on. Before now I want to get the count of employees in my employee table. If you remember, we had inserted 17 rows, so ideally we should get 17. Okay, got it. We have 17 records, 17 count of 17 in the employee table. Okay, so this is what we are trying to solve. We are moving into getting into the analytics part, where we are trying to play around with the table and fetch some numbers, analytics. So I want the count of employee. This is one example. Or you can also check, you can say EMP code as total employee count, total EMP count from employee, again 17. So either you can select a column or you can say select star. Now if there would have been duplicate employee codes, now which is not possible now because we have created a primary key, but if there would have been duplicate, then it would have considered the duplicate rows also as a number. But if you want to remove duplicate, you say distinct. So distinct will remove the duplicates and then give you the count. So in our case, this is a unique employee. Okay, so for example, I want, okay, like my job is repeating, there are different managers, salesmen. If I want distinct job, okay, so now you see there are these the 7 distinct jobs which my employees in my employee table are performing. And if I want the count of this is 7. So out of the 17 employees, only 7 are performing distinct jobs. Okay, there are 7 distinct jobs which these 17 employees are performing. So this is one analysis which is available to you. Okay, next is, if I want sum of total salary which the employees are withdrawing, so this is $51,930 of salary, which the total salary which is being paid out to the employees. So now what you have learned over here is, you have learned this analytical function called sum, and before that we were using count. If you recall, all these functions are also available in your pivot: sum, count, max, median, average. So it's similar to that pivoting. We are doing pivoting using select queries. Now if I want to know the average salary, not the sum, then the average salary which is being paid out is $3,500. $3,054 is the average salary being paid across all the 17 employees. That is the goal. Then next calculation, max salary. Who is receiving the max salary? Okay, 7,000 is the max salary is being paid. Okay, and even okay, so this is the maximum salary which is being paid. Then you have another function which is called as round. This is mathematical utility. You want to round it, your numbers. Let me give this with an example of average salary. So if I remove this round function, I was getting my average salary as 3054.70588 to n number of decimals, but I want to reduce it to 2, round it up to 2, so you can use the round function. Okay, so you have some functions which allow you to analyze the data and like count, max, average, sum, but these round function is the mathematical utility function which allows you to create mathematically create the value, sanitize the value. Okay, now whatever we are doing this, we were playing around with the number fields. You can also manipulate your string fields, right? Like suppose you want to concatenate employee first name and last name and prepare a full name column. Okay, so see this, you have a separate column as first name, separate column as last name, and then you have a concatenated column, first name, last name, and the full name. Okay, so now there are numeric utility columns, then you have string utility columns like concatenation. That is one other example. Then you can also have, you can play around or you can apply logic. Like for example, you want the first 3 characters of each employee's first name. Okay, substring, which we generally is an algorithm which we would have used in a lot of other programming languages, or would have used in day-to-day activity. Or similar to this, you want the first 3 characters, you can use the left function, the left first 3 characters, you can use left function, right? Similar, same output it will give, but you can also achieve that using a different utility function. Left or right 3, leftmost 3 or the rightmost 3. See this. Then you have another function called replace, where you want to replace the last name values, some string value variables, Stark with Adam. So this, in this example, only this, the first employee name would have changed, rest all others are same. Okay, you want to replace a particular value with the other one, so you can use a replace function. Okay, now moving on. This is lowercase. So you have basically another function for string manipulation, converting all your values into lowercase. So you have the function called lower. Okay. Now let's take example of where clause. Now till this moment I was playing around with entire data set. All 17 employees were in my scope of query, but now I want to reduce my scope of data to certain set of employees. So now what I'll do is I'll apply a where clause before performing any other function on my query. I will say only give me those employees whose job is analyst. Okay, and now I will perform my sum of salary. So now if I want, this query is returning me the total salary which the employees are withdrawing with job category as analyst. So this is one analytical example, one query example. Second example for where query is, I want the list of employees whose salary is greater than 4,000. Okay, only 3 out of 17 are the employees who are having salary greater than 4,000. So now this where clause, so see the importance. All the mathematical filters like greater than, equal to, less than, you can perform. Okay, so on number functions. Okay, on string functions you can perform equal to, like for example I want all my job like starting with so if you see this, okay, so now what I have done is I've done a function like any employee whose job category has A and A coming in their job anywhere, A and A within their string, that will come. So manager and analyst have come as an output. So this is like job like. Now if I say, if I remove this percentage, it means starting with A and A, so only analyst will remain. Okay, or if I say jobs which are ending with YST, so analyst again. So this is way you can manipulate the string variables. You can apply a filter on string. Another example is this. Job analyst, but salary is less than 3,500. Okay, so now you have a where clause with and condition. So both the conditions should be satisfied, then only you will get an output. So only these two employees are satisfying this particular condition. Okay. Now let's try to apply a filter on our date column. So anyone who has been hired before 1982, please give me the list of those employees. Okay. So these are the employees whose hire date is less than 82. And how I have achieved that? I just use the year function inbuilt utility. As hire date is a date column, the utility derived the year, and then I'm able to compare it with this value of 1982. Similarly, I can compare the entire date. Select star from employee whose hire date is less than 1st Jan 1982. So I can even go to that level of giving the exact date. Or I want hired in greater than 82 but less than 1993. People who are hired between 82 and 93. Okay, so only 2 employees who have been hired within that particular range of date. Or there is another date utility function called between. Okay, so which means that you want people who have been hired from 1st Jan, between 1st Jan 1983 and 31st December 1992. Okay, and it's inclusive of these 2 dates. So you just always remember, when you are using between clause, it is as good as it's a shortcut for less than equal to and greater than equal to of those 2 dates. So it basically simplifies your SQL syntax. Then there was an employee for which I kept department ID as null. So there could be possible that you want to query data which has null values. So you cannot use this syntax where department ID is equal to null. You need to say where department ID is null. So the database generally behaves very differently when you are dealing with null values. So you need to be very careful how you are writing your queries for the null values. Okay. Now let's take an example of our sorting. So I want the employees to be listed where I am ordering them by salary highest to lowest. Okay. So the maximum salary, as we had queried earlier, is 7,000. So that should come on top, and the minimum salary is 500. That is at the bottom. So all the employees are in the descending order. And if you want the reverse way, you put it ascending, and the lowest will come at the top, highest will go at the bottom. Okay, then now let's take another DML now. So we have talked about select queries, where clauses, order by. Now let's try to update some information, update my data. Okay, now I want to change the job description from analyst to a different keyword where I'm just trying to misspell it. And okay, now let me check. Okay, so the updates have not happened. It's because I first need to run this command to allow my updates to happen. See this, all the job category of analyst has changed to analyst 1. Okay, so I've just renamed it just to show you how an update works. But now I'll roll it back. I'll make my update command correct so that further queries do not get impacted, and it's back to analyst. Okay, now let's look at certain examples of group by. Now I'm gonna take another table called, create another table called employee1 and create it. Okay, and in this I am gonna insert some new data. I'll show you guys. Okay, so I have created a new table. Okay, with the employee ID, employee name, age, gender, date of joining, department, city, and salary. Now I'll try to apply, show you some examples of group by. So now I want per department total salary being paid. Okay, in this example. So what I'm going to show you is select star from employees. Now my question is per department. So when I say per department, you say group by department. Then whatever column is in the group by, only that can be used in the select. Rest, any other column you want to use, you can use only with these analytical functions like sum. So if you say salary per department, now this is my answer. Per department I am paying this much salary, and if you notice, so if you have to derive this, you have to group by department. Okay, if you want to see how much average salary per department you are paying, you just need to change the function from sum to average. The max salary you are paying per department, you just need to change. So in sales department, the maximum salary which has been given to any of the employees is 1,15,000, marketing 67,000, product 76,000. So this is your answer, right? So you can perform any kind of analytical function. Okay, now I want, let's go back to my select star employees. Okay, so in my employees I want per city, how many employees I have, right? Per city. So now I'm asking you per city, you say city, then in the select only you can use city and you say count of my employee ID, okay, EMP ID. So I'll get the answer that in how many, in each city, how many employees I have employed. Chicago 4, Seattle. Now if you see this information, this is not sorted. I want the maximum number of employees per city, so you can just say order by count descending, and now the information isn't sorted. You have Chicago has the maximum, Detroit and Austin have minimum 2, and this is a sorted list of city wise count of my employees. Okay, now let's go back to this data. Now I want how many employees joined in 2005 per year of my joining. In X year, how many have joined? Okay, so what I'll do is I'll say group by year of date of joining, count of employees, order by, this rest remains same. Okay, so if you see in 2009 the maximum number of employees joined, then in 2011 in 2005 you can also order by actually year of joining, descending like this or ascending. This will make sense. Okay, so from 1999 till 2019, how many employees joined per year in my firm? So this is that particular example. Okay, now moving one step further, we want to use having clause. Okay, so now I want to do filter after performing my group by. So what I'm trying to do is I have identified what is the average salary in my each department, and I want those departments where average salary is less than 80,000. Okay, so only if I don't have this having clause, I have 2, 3, 4, 5, 6, 7 departments, but out of these 7 departments only 5 have average salary less than 80,000. So this is a filter after you have performed a group by. So this is one very important example which I wanted to show you. So where clause is before you apply group by, and having clause is after you have applied group by. Okay, similarly when we did a group by city, we can perform this calculation. Only those cities which have employee count of equal to 3, only give me those. So this is that particular list. Okay, where count is equal to 3. Having, so after applying having, after applying group by, I am further filtering the data. Okay, now coming to the other very important aspect is coming back to my old table of employee and department. I want to now make a join between my employee and department table. Let's forget about the employee 1 table. Now I have a common column between employee and department table is the department ID. Okay, so what I'll do is I'll say select star from employee E, comma, department D, where E dot dpt underscore id equal to D dot dpt underscore id. So I'll say give me the E dot star, comma, D dot star columns from both the tables only when my data is matching. So only those records will come for employees who are having a corresponding department ID in the employee table. Okay, none other than that. So if I take a count of the rows, it's 16, but originally I had 17 because there is one employee whose department ID is null. So that employee will not come in this result set. This particular employee code is not part of this result set. Nine triple seven. So if you see 9777 is not here. Okay, it's because the null value cannot be joined with any other column, so that particular row has been ignored. So this is the meaning of join. It means look up all the department IDs from the employee table and then look up in the department table, whichever matches, please bring that as an output. That is the, so this is an example of inner join. This is what we call as inner join. Now I'll also give you an example of subquery. So if I say give me the employee name and salary from the table, okay, which is the top four salaries, okay, so these are the 4 employees which have the top 4, and amongst them the highest this is the highest. Okay, so what I've done is I have written a subquery which says give me the top 4 employees who have the highest salary, and out of those top 4 I am picking the one which is having the highest salary amongst the 4. So this is an example of subquery. So you first write an inner query, give it an alias, and then on top of it you write another query. Okay, so now I'll take certain Q&As. Anyone has any questions, we can take that up. Okay, so limit means that out of the number of records, I only want to limit it to number of records. So like for example, I have select star from employees, order by salary descending. Okay, this we have already seen. So I have ordered my employees by salary from highest to lowest, and out of that I only want the four records, the top four records of this. So I'll say 4, limit to 4. Okay, so when I say the subquery, so subquery is nothing but an independent query. So first you say order by salary descending, then you take the top 4 employees. Now out of these 4 employees, this is now my independent result set. On this result set, now I am again writing a query on top of it, select employee name and salary only from this result set, and then again order by salary descending or even ascending, and you will get the lowest one. Then you can play around with it. This is the one amongst these 4. Jack is the one who has the lowest salary, and if you make it descending, Joseph is the one who has the highest salary amongst these 4. Okay, so limit means limiting your result set to a particular number of record count. So there are limitless possibilities. There is no limitation. As you advance into SQL world, there are so many possibilities, so many problem statement. But this is just a stepping stone into the particular direction. So it will help you learn further and advance into more analytical functions. Yeah, we can write multiple subqueries. There is no limitations. You can create this is one subquery, then you can another subquery you can write, but just give a alias as different and say order by salary limit 5. That way you can create n number of subqueries. Okay, I hope everyone had a great learning session, and will definitely help you guys in further advancements in the analytical space, and I wish everyone best of luck. Thank you.